Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we're going to continue our discussion of the other collection types, and in particular we're going to talk about the maps collection type. Now maps are a little bit different than the other collections that we have discussed. One of the big differences between them is that they have parametric polymorphism, but they're parametric on two different types. So let's look at what we can do with a map. So we can build a map. Now one of the things about maps is that they associate a key with a value. And so let's do this. I'll first use the long syntax for doing this. Three. Okay. That is one way of building a map. And so the map takes arguments that are tuples. There are two tuples. The first value is the key, the second value is the value that that key relates to. So in this case I've made a map, and note that once again maps exist in both the mutable and immutable form, and by default you get the immutable form. And this is a map from string to int. You'll notice that when it prints it out, it uses this arrow notation, and in fact most of the time when you are creating maps, that is what you will do. You will use an arrow notation instead of the standard tuple notation. The reason for doing this is basically because it's easier to read, it's easier to see what's going on. This tells you that the string 1 is associated with the number 1, string 2 is associated with the number 2, etc. So the primary reason for using a map is so that you can look things up, and you can look them up quickly using the key value. So if we look for the value string 1, we get back the value 1. The keys basically form a set. So if I take res1 and I add to it 2, 5, you'll note that my 2, which went to 2, has been replaced by now the string 2 goes to the value 5. Now why would you want to use a map? When you used, so for sets, all you're doing is you either say something is there or something is not there. For sequences, you have a bunch of values, and they are, in some ways, you keep track of them by their index. The index is the way that you store them, it's the way that you look things up. A map gives you the ability to store and look things up by something other than an integer index. Now, even if your key value is an int, there can still be advantages to having a map. So, for example, let's say that I had something that looked like this. So I was keeping powers of 10. Actually, let's go with, I can even do a map of int to int. Anyone notice the trend on this? Yeah, I'm doing log base 10 here. Now, if I had decided to keep this as an array, or as an array or some other sequence, my indices here were 1, 10, 100, 1000, 10,000. There's a lot of blank space between 1 and 10,000 here. And all of that blank space would have been wasted if I used a sequence. But in a map, even if my key values are ints, it can still be beneficial because it gives me a fast way to look things up, and it only uses the amount of memory that's associated with the number of things that I'm storing. Technically, many of the implementations might use twice as much as what we're storing, but if I were to actually store this in an array, I'd be using almost 10,000 times as much as what I'm storing. Definitely, let's see, I have 5 values and I'd have 10,000 elements, so I'd be using 2,000 times as much storage as what I actually needed. Other thing to note, order does not matter. Okay, this is not the order that I gave the things into it. That's very much like a set, and then I can look things up in here and get back the values. A possible usage for this would be, let's say we had a case class for a student, and our student has a name, which is a string, and I'll just say they have a grade, which is an int, and we would probably have lots and lots of other things. I could have a map that keeps track of students by their name. So let's make a sequence. Students equals a sequence of student Mark 90, student John 80, student Jane 95. Okay. And the thing about keeping it this way, so I could, if I want to look up someone by their name, I can do something like students dot find underscore dot name equals John. Okay, I can do that here, and it gives me back as an option. But it would actually be nice to have, and so one thing about that is that find technically has to run through everything until it finds the thing that you're looking for. So if I had a very large sequence here, find on a sequence is order in, and that can be very inefficient. The map typically has a much more efficient implementation for finding things, especially when you have a large number of them. So I'm going to make a student map, and that's going to be equal to, and then the question is, well, how do we do something like this? One way to do this would be to take the map, and what I'm going to pass into this map is students dot, and now I'm going to use the map function, where s goes to s dot name arrow s. And then to make it so that it takes this as a set of, as a bunch of tuples as arguments instead of just as a single sequence, I can do that. And you can see here that I got an immutable map of string to student, and now I can take StuMap and look up Mark, and I very quickly get back the student record that is associated with that name. Let's see, so there is a toMap method that you can use. Now it has to have a tuple, so this would actually be the student map s rocket s dot name arrow s. That will give me back the same type of result, and this version is a little bit more brief and might be more readable. Of course, you can't take just any sequence and convert it to a map. You need to have something that is a sequence of two tuples in order for this to work. So that's kind of a quick rundown of maps. Turns out maps are remarkably useful. We're going to use maps significantly more than we use, say, sets. Maybe not quite as much as we use sequences, but we'll use them for things like we need to be able to look stuff up by a string. Pretty much anywhere in our project where we want to look something up by a string and have it be efficient, it can be good to make a map of those things. So in the next video, we'll do exactly that. We'll come back and we will start using these collections to add some more features or to clean up things inside of our project. So we'll see you again soon.